Hello students! So this video here is about the vertex form of quadratic functions. And so this particular form is one that can be written, usually it's written as part of it is written as a perfect square binomial. And so you'll see a coefficient. Well, you may or may not see a coefficient in front of that perfect square binomial, and then you may or may not see a number added or subtracted on the outside, and you may or may not see a number added or subtracted on the inside of that parentheses. And actually, it doesn't have to be written with parentheses, but again, the form, that form for the vertex form, the way that it is written is y equals, or it could be f of x equals, but y equals a times x minus h squared plus k. All right, so and again, the part that's being squared is x minus h. And again, folks, we're going to look at what each part represents. And guys, first off, it's very important for us to know that in this particular form, this vertex form, this is the form where it is the easiest to identify the vertex. And we get that, of course, by just listening to the name of this form, right? It's called vertex form, right? There's nothing complicated about that. Again, in this form, it is very, very easy to identify what the vertex is. So, again, guys, it is very easy to identify the vertex in this form. And guys, for this vertex form for quadratic functions, when we look at an equation, and again, the only parts that'll still look exactly like this when we're looking at an actual equation is, of course, the y, which represents the output, and the x, which represents the input, right? So, of course, for a, you'll actually have a number written there. For x, for h, you'll have a number written there, and for k, you'll have a number written there. But guys, the actual vertex for this form, the vertex for this form comes from looking at two of those variables. Comes from looking at the h and looking at the k. So the vertex, of course, which is going to be an ordered pair, the vertex in this form is going to be hk, an ordered pair of hk. So again, guys, the vertex is going to be hk. Now, when we're looking at an actual equation and trying to actually identify what the k value is, what the h value is, let's start by looking at the k. And of course, I'm going to show you some examples where we actually, where we look at some actual, equations, some actual functions. But again, when we look at this particular part where you see the plus k, when we look at that part, the k value is always going to be the exact same as what you see in the equation. It's going to be the exact same value as what is seen in the equation. The k value, the value of k. In other words, that y value for your vertex. That's what we're going to get for k, but it's going to be the exact same as whatever you see in your equation. And then, guys, when we look at the h value, at the value for h, which is again that x value of the vertex, when we look at the equation and we see whatever this number is here, when we're trying to identify what h is going to be for the vertex, guys, we are going to actually have to use the opposite sign. Okay, so when you're doing k, the y value for the vertex is always going to be the exact same value as what you see in the equation. But when we're doing the h value, which is the x value of the vertex, you're going to have to take whatever the you're going to have to use the opposite sign of what you see in the equation. Okay, so again, guys, the y value of the vertex is always going to be the exact value as what is seen in the equation for k. And then the x value for the vertex is going to always use the opposite sign of what you see in the equation for h. Okay, so let's look at a quick little example with just identifying the h and the k. We'll come back to the a in just a little bit. Okay, so let's look at this example here where we're asked to identify the vertex. Okay, identify the vertex of y equals 4 times x plus 3 squared, the quantity of x plus 3 squared, minus 5. So again, some of you can probably already tell me just based off of what I've already told you. Some of you probably can tell me exactly what the vertex is right now, because I've told you that the y value of the vertex is going to come from the k in that equation, and it's going to be the exact value as you see it in the equation. And I've told you that the x value of the vertex is going to come from the h part of the equation, and you're going to have to use the opposite sign of that. So some of you might be able to tell me exactly what it is right now, but again, we're going to look at exactly how to do this, or we're going to look at the way that I want you to show me how to do this. Right now I'm talking specifically to my students, where you are enrolled in my classes, and this is for the assignment that I've assigned to you. I'm going to show you the exact way that I want you to do it. But for right now, I'm just going to explain why it works this way. I'll show you exactly how I want you to do it a little bit later. Okay, so I'm gonna use this particular form to explain well, the y value of the vertex should be pretty self-explanatory, but I'm going to use it to explain again how we get the x value of the vertex, really. So again, we clearly already know what the a value is here, what the exact a value is. Again, we'll talk a little bit later about what that a value determines, or what it can determine in this vertex form. All right. We're going to come back to the h part. Let's do the k first, right? So again, the k works because in order for it to be equivalent to a -5, this would have to be the same thing as being plus -5, right? Do you agree? You should. All right, so again, this would have to be the same thing as plus -5, right? Because adding a -5 is the same thing as -5, right? So that's why k is what it is, okay? Now let's look at the h part, though. So for the h part, I'm going to put something wrong the first time. I'm going to put the wrong value. So some people might assume that h is going to be the exact same way that k was. And so if you assume that, then you're going to assume that, and that would be wrong, right? If you assume that h is going to be done the exact same way that k is, then you would write h as +3, right? And that would be completely wrong. The reason why h is not +3 here, again guys, the reason why h is not +3 is because if we simplified the way this is written right now, and I'm going to erase this in just a second, but if we simplify the way this is written, then it would be simplified as x minus 3, right? Because I mean that's the only way you can see that. If h was a positive 3, then this would be x minus 3. Using this form, if h was a positive 3, the equation would have to be written as x minus 3. I mean that's the only way to look at it, if h was positive 3. So again, that lets us know, guys, that h must not be a positive 3. So again, I'm going to erase that. So clearly, guys, h is not positive 3, but h is negative 3, right? So h is negative 3, and again, if we simplify it this way, where h is negative 3, the only way for us to simplify that, guys, is for us to, and you realize already what the coefficient is on the outside of the inside set of parentheses, right? The coefficient there is a 1. Technically, it's like we're saying minus 1 times, right? It's like we're saying minus 1 times h. Okay. So again, it's like that. So the only way for that to work, where it is still equivalent to this original equation, where it simplifies to being x plus 3, is the fact that h has to be negative 3. Again, h has to be negative 3. All right. So again, if h is negative 3, then it is going to simplify and is going to actually wind up looking exactly the same way as this equation does. Okay, with the, you see it. You see where my mouse is. All right. So again, it's going to look the exact same way as this one, but only when h is negative 3. But again, guys, this was just a little explanation of why it works. But again, guys, if you use what I've explained to you here, what's written in red, then you shouldn't have any troubles with that, because I think it's pretty self-explanatory for us to say that the value of h is, or that you're going to use the opposite sign for h, and you're going to use the exact same sign for k. I think that's pretty self-explanatory. I could be wrong, but I think that it's pretty self-explanatory that you're using the opposite sign of what was in the written in the equation. That again, h is negative 3, which is the opposite sign of what was written there, even though it did say, ooh, that's sloppy, let's try that again. Even though it did say plus 3, again, if you just use what I told you there and use the opposite sign of what's written in that equation, if you use the opposite sign there, then you should be able to get that h is negative 3 again. And then if you use the exact sign for what k is, the exact sign as how it's written in the equation, then you get the k equals negative 5. And so since that is true, guys, and again, it is true, since that's true, then our vertex is and can only be, again, that hk, which is negative 3, negative 5, for this example, that is. I hope that makes sense, guys. So we're going to look at a few more examples, at least 2 or 3 more examples where we're just identifying the vertex. And then, guys, I'm going to show you show you exactly how I want you to show the work for what I'm asking you to do in the particular assignment that I've assigned to you, my students who are enrolled in my classes. But guys, before we look at another example or at a different example, let me make sure that I explain what that a value helps us to determine. So again, we use the h and the k from the vertex form to determine what the vertex is. But let me make sure that I explain what the a does. So again, guys, for this particular example, your a value is 4. And so that should be pretty clear to see, because again, that's the number that's written in front of that perfect square binomial, and it's the coefficient for that perfect square binomial that you see in the parentheses. And so so the a value is 4, and again, what that a value determines is whether or not your parabola is going to open up. So again, parabolas are U-shapes. They either open up like this, and if they open upward like this, then that means that they'll open up if the value of a is positive. And again, when it opens up like that, when the value of a is positive, there's going to be a minimum value. So that value, or that point at the bottom of it. So again, a quadratic function is going to have a relative minimum if the value of a is positive, like it is right now. And then, of course, the opposite is true. If the quadratic function had a value of a that was negative, then that quadratic function would open down. It will be a U shape that is opening down, okay, like an upside down U. And if that was the case, then it would have a maximum, okay? So that is what the value of a determines. There'll be a relative maximum if the value of a is negative, and there'll be a relative minimum if the value of a is positive. Okay, so again, guys, if the value of a is positive, your graph for the quadratic function is going to have a relative minimum, which means that it's going to, oops, did I do that? I sure did, folks. Why y'all let me do that? That's okay. That's all right. We'll have a relative minimum. There we go. If the a value is positive, and the graph will have a relative maximum if the a value is negative. There we go. Much better. All right. So guys, if we put all of that together, if we put it all together, the a, the h, and the k, and what the three things determine with the vertex, and whether or not there's going to be a relative minimum or relative maximum, then what we can surmise, or what we can pretty much get from that is the fact that for this particular equation, the y equals was it 4 times x plus 3 squared minus 5. So for this particular function here, if we just wanted to do a little sketch of the graph, not an actual coordinate plane, but just a little sketch of how this graph would look, just using that information that we just now determined based off of the a, the h, and the k, then this graph would, because the a is positive, it would have a minimum, and again, the graph would open up. Yeah, that is sloppy, but it's okay. The graph would open up sort of like that. Still sloppy, but it'll work for now. Yeah, that's better. Alright, so the graph will open up like that, your vertex, of course, is going to be -3, -5, based off of that information of h and k. Vertex, -3, -5. I'm actually going to write that somewhere else. The vertex would have to be -3, -5. And again, hopefully you guys remember what the axis of symmetry is. You shouldn't have forgotten it already, right? The axis of symmetry for quadratic equations is going to be a vertical line that goes right down the middle of that parabola, and it is going to split that graph into 2 equal halves. So hopefully you haven't forgotten that about axis of symmetry. But again, that's what we can get so far out of just knowing how to identify these particular parts from the vertex form. The axis of symmetry is going to be this vertical line. Yeah, I think that'll work. Yeah, right here. And I'm making it dotted because a lot of times that axis of symmetry is not actually seen, but it's there. It is there. A lot of times it's just not seen though. Alright, so that axis of symmetry would be right there, and the axis of symmetry would have. Do you guys remember how to write the equation for axis of symmetry? I hope so. The axis of symmetry would have the equation of, it would have to be written as an equation, and you would have to write it as the equation of a vertical line, and you'd have to write it as x equals, and you'd use the x value of the vertex. So it would be x equals what we had for h, which is technically x equals -3. All right. So when we're doing the vertex form, we can pretty much figure out the basic sketch of how a graph is going to look, and you can do that with the other forms too. But again, if you know the vertex, you know which way the graph is opening up, opening down. You can figure out what these other points are around your graph. And again, that's how I'm going to want you to show your work for the particular type of exercise that you're going to be doing on Khan Academy. My students who are enrolled in my classes at our school. Okay, and I'm about to show you that after I show you a few more examples. But I am going to show you the particular way that I want you to work it out with these next examples here. Okay, so I'm going to show you these examples, but with these examples, I'm showing you the exact way that I want you to work it out, where you're graphing these particular functions on Khan Academy, on your Khan Academy assignment. Okay, guys. Just really quickly before I show you those examples where I'm also showing you exactly how I want you to work it out. Just really quickly, let me mention here let me mention and explain what happens if the h value is 0, or what happens if the k value is 0. So in other words, if the h and the k, if either the h or the k is 0, I need for you to know how the equation or how that function is going to look. How the equation is going to look if h is 0 or if k is 0. So I'm going to write this real quick, but I'm going to erase it afterwards. So I need for you to know how that will look. Okay, guys. So if h is 0, it might look something like this if h is 0. So you'll still have some type of, and actually I'll use pretty much the same equation that we already had. I'll just write it so that h is 0. How about that? I'll keep the same a value, which was 4. I'll keep the same k value, which was, and by the way, let me go ahead on and do that the right way. All right, so guys, if h is actually 0, then it's going to wind up not being written, or it's going to wind up being written without parentheses, or at least it's an option as far as whether or not you're going to write it with parentheses or without parentheses. But again, if h is 0, there's not going to be any number inside the parentheses with x. So there's not going to be any number inside the parentheses with x that is being squared. So if there's nothing here that's being added or subtracted to x that's also being squared, if there's nothing there, or in other words, if it's literally minus 0, x minus 0, or anything minus 0 is just itself, right? So if you got something minus 0, you don't have to write the minus 0. Does that should make sense to you, right? So since you don't have to write the minus 0 in this form, then there's really no need for you to have the parentheses there at all. Again, it's just a personal choice as to whether you'll even write the parentheses or not. So yeah, if h was 0, you could write it without parentheses at all. And again, then you would still have the k value. Again, the k value is not a part of what's being squared. Again, the h value is always a part of what's being squared. So it would look like this if your h value was 0. Again, I'm going to erase this, but again, it would look like this right here if the h value was 0. Okay, you could write it like that. Again, folks, you could write the minus 0, but most of the times, again, folks, it's not going to say, you're not going to see it as you're not going to see it as x minus 0 inside the parentheses and squared, because most folks, they know that there's no need to put the minus 0 there at all. So again, all right, so that's how it will look if h is 0. I'm going to erase this, and then we'll look at how it's going to look if k is 0. Okay, so if k was 0, oop, that ain't if. Try that again. If k was 0, was equal to 0. Again, I'm just going to use that same equation that we had already used, but instead of k being -5, we're going to write k as being 0. So if k was 0, it would look like this. Your a value would still be 4. If h was still -3, it would look like this. And again, if k was 0, guys, there's no need, absolutely no need for you to write a plus 0, right? If you're adding 0 to something, it would just be whatever it is, right? You would not need to put a plus 0 on the outside. So again, I'm erasing this, guys, because again, folks, you will not need to have a plus 0 written there at all, because it's understood, guys, that if you're adding 0 to something, that there's no need to actually write plus 0. Why would I write 3 plus 0 instead of just writing 3? Right? There's no need to do that. All right, so that's how it would look. This same equation, that's how it would look if your k value was 0. All right, so next I'm just going to do real quick, how would it look if both if both h and k were 0. Okay, so if h equals 0 and k equals 0, then it would look a certain way if this thing would act right. There we go. If h equals 0 and k equals 0, then again, if I was using that pretty much that same equation as what we already have here, if h and k was equal to 0, but we still had the same a value, then it would just look like 4x squared, right? If the a value was 4, but if both h and k were 0, and if both h and k was 0, then the vertex would be 0, 0, right? It would be the ordered pair of 0, 0, which means that the vertex would technically be the origin on a coordinate plane. It would be the origin, which is that ordered pair 0, 0. All right, but again, that's how it would look if both h and k were equal to 0. Because again, there'd be nothing there on the inside of the parentheses or inside of with the x that's being squared. There, you wouldn't have to write the plus 0 there or minus 0 there, and you wouldn't have to write a plus 0 on the outside for the k either. Okay? Okay, poof, be gone. Alright, so now we're going to go ahead and look at a few examples where I'm actually showing you, this is particularly for my students who are enrolled in my classes, where I'm showing you exactly how I want you to do that Khan Academy assignment of graphing vertex form for quadratic functions. So again, this is how you're going to have to show your work for the Khan Academy assignment that I've assigned to you. So let's say that your example was something like graph y equals -2 times x minus 1 squared plus 9. And so if we were going to do this, and the way that I want you guys to show your work is to first identify your a, your h, and your k. Identify what h is and identify what k is. Alright, and you should kind of be familiar. And actually, guys, what you need to do is pretty much, even though they've got this equation here, what I'm going to want you to do is write out the that form for a vertex form. In this form here, I'm going to need you to write that out. That's going to help you when you trying to identify what a, h, and k are, right? So write out that form somewhere, all right, and use that to help you identify what a, h, and k are. All right, so a is clearly -2, right? That's that value. And k is clearly 9, right? So remember, guys, we said that you use the exact value for k, that you use the exact same value. All right, and remember, guys, we said that for the h, you have to use the opposite sign of what you see in the equation. So for the h, the opposite sign of -1 is +1, right? We know that. All right, so everything, the other two parts, or the other two components, a and k, that you take those at face value. Whatever those are in the equation, -2 and +9, whatever they are, you just write that exact value take the exact same sign, the exact value as it is for those two. The only one that you do the opposite sign for is H. Alright, so once you've identified A, H, and K, go ahead on and tell me what the vertex is. Tell me what the vertex is using these two here. Alright, so you should know that using these two, and I want you to write it out like this. The vertex is HK. I want you to write it just like that right there. And that means that your vertex is -2, 9. So your vertex is -2, 9. Again, that's how I want you to write that part there. And you're showing your work. Also, guys, for whatever that A value is, remember we said that the A value here for this vertex form is going to determine whether or not your graph is opening up, which means if it opens up, that means that you'll have a minimum, or whether or not your graph is going to open down. And if it opens down, that means that you'll have a maximum. So when the A value is negative, you're going to have a maximum, and the graph or that parabola is going to open down, and you're going to have a maximum because of that. So again, you'll wind up having a maximum. The vertex will be a relative maximum. I want you to write that out. Okay, so write what the vertex is. Again, you'll identify A, H, and K. You'll write out the actual form, like the legit form for vertex form with the A, H, and K. What I've got here in red, you'll write that out. You'll tell exactly what the vertex is, and you'll write it like this with the HK first, and then you'll write the ordered pair using those numbers. Yeah. Why y'all let me do that? Why did y'all let me do that? See, that's how long of a day it's been. Why y'all let me write that for the vertex? It's okay. Vertex is 1, 9. Yes. Alright. Alright, so the vertex is 1, 9. This will be a relative maximum. And then what I want you to do, and again guys, what I want you to do is just do a little sketch here. This is for the work that you're showing to me that you have to write on a separate sheet of paper for those Khan Academy assignment. Again, just do a little sketch here. Just do a little sketch of what this graph is going to look like. Again, it doesn't have to be anything. You don't have to actually put a coordinate plane on the work that you're showing for me. But just do a little sketch. So that's clearly a parabola that's opening down. That's going to have a maximum, a relative maximum, right? Relative maximum. All right. And again, the vertex there is going to be that 0.19. Okay, so you got to do that when you're showing the work for me. And there's one more thing that I'm going to need you to do, because again, the Khan Academy assignment is asking you to graph. So you're not done yet as far as showing the work for me for these types of problems. I'm going to need for you to show a table of values. So again, the things I'm going to need you to show. I'm going to need you to put a table of values up here. Alright, where you're showing. And again guys, for that table of values, I'm going to need for you to write out the vertex in the middle. Yeah, that ain't exactly how I wanted that to look, but that's okay. So again, put the vertex in the middle. So that point for the vertex 1, 9 in this particular example 1, 9. So put the vertex in the middle, and then guys, I want you to show. Ooh, that's sloppy. Ooh. All right, give me a sec here. Oh, that looks so much better. All right, so again, I want you to put a table of values, and I want you to have the vertex in the middle. So I need for you to have the vertex in the middle, and I need for you to actually, I need for you to put the other points that are going to be around it, directly around it, there. Again, guys, if you want to use Desmos graphing calculator to help you get those other points, that's fine. Like again, if we do that. Okay, so again, folks, if you want to use Desmos graphing calculator to help you get those other points, again, our vertex here was 1, 9. But again, folks, remember, you're going to need to show your work this way, the way I was showing you up here, where you list out your A, H, and K value. You identify your vertex, and you write it like I've got it written here. Doesn't have to be written in the exact place where I've got it, but you need to write it pretty close to how I've got it right here. Write out that the vertex comes from the H and the K form, and again, remember, folks, that you do just take the opposite sign of the number that's there with the X inside of the parentheses. You do the opposite sign of that, and the other two for H and K are the exact same values. So you'll write out the vertex. You'll tell me that the vertex is either relative maximum or relative minimum. Just kind of sort of let me know that you know that the A value is determining that, and then just do a little sketch for me. Okay, so do a little sketch for me of how that looks, and then I'm gonna need you to do a table of values. All right, so again, we can identify those other points. Let's see, I'm just going to let's see if we can do that. There we go. Oh, nope. Let's try it again. I put that was, what was that? Nope, it wasn't that one. Nope, it wasn't that one either. I'm having a little malfunction issue here. It was just showing up. That's all right. Oh, there it is. I'm tripping, y'all. Yeah, that's the exact same one I was just looking at. It just looks different now that I've minimized it. That's what it was. Haha. See, they trying to trick me. They can't trick me. Alright. There we go. Alright, so that point was 0, 7. Again, if you want to actually see those points up there, you can do that. And again, the vertex was 1, 9. 1, 9. 0, 7. Again, you don't have to do this here, but I'm just doing it. The next actual point on the left side, the next point is that one. -1, 1. Yeah, that's it right there. -1, 1. The next point, or the next point that has both that has a whole number for both the X and the Y value. Let's put it that way. All right, it's negative 1, 1. Alright, so those points there that were on the left side of the vertex, those are going to be written above the vertex. Okay, and let's move that over so we can actually, alright, 0, 7, negative 1, 1 were those 2 points there. Alright, and then the other points that were on the right side are exactly symmetric to these other points. What's that? 2, 2, 7. That one. Two, 7. All right, and then the last one there is 3, 1. Yeah, come on, 3, 1. There we go, 3, 1. All right, that one right there is 3, 1. So again, these 5 points are what I need you to have in your table of values. But again, the 2 points that are on the left side of the vertex need to go above that vertex, and the 2 points that are on the right side of the vertex need to go below that vertex in the table of values that I want you to show for your work. Because you got to show your work to get all of the points for this assignment. Yes. All right, so that was 3, 1, and 2, 7. 2, 7, and 3, 1. 2, 7, and 3, 1. So, guys, you see how these x values, the way I've written this table, how the x values are in order? Negative 1, 0, 1, 2, 3. They're in order from the least to the greatest. That's how you need to do it as well. And you see how the y values are sort of look like they're repeating. They look like they're symmetric around that vertex. How you see the 1 and the 1 like that, and then you see the 7 and the 7 for the y values, and then you see that lone 9 in the middle. That's how you need to have it. Okay? So this is how you need to show your work for me when you're doing that Khan Academy assignment, okay? And you need to show all of these things here that I've asked you to show, okay? Again, you need to label your A, H, and K. You need to tell me what the vertex is. You need to let me know whether or not it's going to be a relative maximum or minimum. You need to do a little sketch for me, and you need to show me your table of values. You need to do a table of values where your vertex is in the middle, and these other points are around that vertex, like this. So again, folks, that's all. Again, let me just show you real quick. Again, how that graphing assignment on Khan Academy is going to look, and exactly what you're going to do with that. Because again, it's like a part of it is like a click and a drag. But let me just show you how that's going to look. So again, guys, this is how it will look on that Khan Academy assignment. Again, after you've shown all the work here that I'm asking you to show. And by the way, I also want you to write out that form as well. So everything I got a blue asterisk by, yeah, I want you to show all of that in your work, okay? For this particular question set on Khan Academy for this assignment. So again, this is how the assignment is going to look on Khan Academy. You're going to be asked to graph this in the vertex form. Okay, so the first thing you're going to do is go ahead on and click and drag this this vertex to wherever the vertex is supposed to be. So if I was going to graph the example, not the actual problem that you saw there, because you might actually get that problem. So if I was going to graph this example where our vertex was 1, 9 up here, then I would put that 1, 9 right there. I would click and drag that vertex right there, and then all I would have to do is I would have to move this point to any of those other points that I had in the table. Any of the other points that I had in the table. It wouldn't matter which one, as long as I picked at least one of those other points. So I'm going to pick 0, 7. Again, it doesn't matter which of these other points. But you do need to drag that vertex to wherever that vertex is supposed to be. So again, for our example that I just showed you, 1, 9 was the vertex, and again I can choose 0, 7 as the other point, or I can drag it to, again I can do 2, 7. Again I can do what was that other one? Negative 1, 1. Again, it's the same vertex, the same parabola, or I can do the other point of 3, 3, 1. Okay? So again, it doesn't matter which of those other points you choose, it's still going to do it right. But again, just to show you real quick, I know that this is the wrong graph for what you're seeing up here right now, but again, it's the right graph for what we were doing on for our particular example here. So again, guys, when you get it wrong, you got an option to try it again. So you can't say that you didn't have another option to try it again. Check again, right? So you can move stuff around. Again, I'm gonna get it wrong again, just so you can see. Check again. Oh snap! I can still try it again. You got unlimited chances here to try it again on Khan Academy. Unlimited chances, unlimited. Or at least I believe that it's unlimited. Try again. See how many times they're telling me try it again? And you see all of these things here. Get help. So again, if you need help with something, they've got like little tutorial videos, little short tutorial videos up here or examples that you can look at up here as well. If for some reason you chose not to watch my video where I've explained this to you in detail, that's fine by me. But again, you will need to watch my video so you can do the discussion questions. But anyway, yeah, that's it, folks. That's all. Make sure you show your work, showing all of these things that I've shown up here, where you're identifying these things and you're writing out these things that I've asked you to identify, these things that have blue asterisks beside it, where you're identifying, yeah, all of that I've already said more than once. Yeah, that's it, folks. I hope that this has helped you, and that's all. Look at the time. Look how late it is. Yeah, alrighty. Good night. Bye-bye. So long. Farewell. That's all.